Gravity motor for gravity microgenerator, battery, or maybe a clock project for children. In the future, we may need like that a gravity engine in several applications where only need a small amount of energy. This motor can give a larger energy package at specified times and without a hitch. Anyone who hasn't tried it might think this is a simple task, but it's not. For example, if I want over more than 24 hours only weight of 1 kilogram let down 2 meter long, it is not an easy task at all. This is the first experiment and the first version with this method, so there is not much data and experience yet, but I see an opportunity in it, that's why I'm sharing it. Actually, I was thinking about a clock for children and I made it up this structure. So the other application could perhaps be a lesson project for children. Those who love science also love classes. The clock is one of the earliest machines developed by man and one of his most important inventions. I think building a clock is a great science project for anyone. However, a watch is much more complicated and much more difficult to make than the layman might think. In fact, every watch is a masterpiece. My goal was to make a simple clock that doesn't go astray for more than half an hour a day, works for at least a day, and has such a simple and transparent structure that a 10 to 12-year-old child can easily understand its operation and even build one. Even a medieval person would have been happy with such a structure. The first challenge in the watch is to be able to operate a gravity engine and system for more than 24 hours at all. This is already a big challenge, namely, because of the square-cube law. This roughly means that every structure has a certain ideal size. What we can do well on a small scale, we may not be able to do well on a large scale, or vice versa, and in relation to the ideal size, we cannot do it well on a much larger or smaller scale. This is because as the size of the whole system changes, the characteristics of the parts change to different degrees. If a child, or an adult like me who is not too smart, and not patient, wants to make a watch, it is about possible for him if his clock can only run for 12 hours without stopping. I think that a clock can be called a clock if it works for at least 24 hours and is no more inaccurate than half an hour in the one day. That's about all the early hours knew. My next thought was to do more hours and run the motors in sequence or alternately. However, I haven't found a mechanism that is sufficiently simple to accomplish this. The other possibility is some kind of escaping structure that has a slower or finer resolution than solutions based on simple friction or pendulum. I first tried a water clock, but it's unbelievable that it knows exactly the same as traditional mechanical escapement mechanisms. That is, the conclusion is that approximate 12-hour operation is easy to achieve, but 24-hour operation requires the creation of a masterpiece. With the water clock, the surface tension of the water is the obstacle. The solution seems to be to make not a water clock, not an hourglass, but an air clock, in a way that is as simple as a water clock. All mechanical clocks change speed in response to ambient temperature. They were able to reduce this with pendulum clocks and various inventions. Then the accuracy improved due to better escapement mechanisms, as well as miniaturization and more precise workmanship. The viscosity of air also changes with the air. Unlike that of water, it increases as a result of warming, but I do not yet know how much this difference means on a daily basis in the case of such a watch. The temperature in the apartment is pretty much constant anyway, so maybe this wouldn't be such a big problem. Since this clock is based on friction and not a pendulum, it is definitely not that accurate. As the temperature changes, not only the size of the materials changes, but also the friction, but maybe that wouldn't be a problem either. However, when we use gears, the torque passing through the gears will also constantly change, due to the inaccuracy of the gear and the fact that the teeth press against each other at different distances from the shaft. So a clock based on friction is even more inaccurate in smaller time units than in larger ones, where these differences balance each other out and give an average. The unevenness of the gear system can be corrected by using several motors and/or gears in parallel. Of course, if we don't achieve medieval precision, this gravity engine will still fulfill the challenge of working for more than 24 hours much more reliably, easily, and simply, and maybe it can be the basis of a clock or something else,